Well, it was back in 2001 when we started to see this 3V trend in industry: data volume, velocity, and data variety. But that was back in time. Now that we are operating on a more sophisticated analytical world, those 3Vs are now turned into 42Vs. Amazing, isn't it? Are you excited to check it out? I'm going to leave the link below for you to check out later. In this episode, I'm going to talk about just one V, which is the velocity. A V that is out of those 42 Vs. Rather, instead, it is one of those initial Vs. Excited to begin? Smashing that like button. Welcome to Masterly Data. I'm Raza, and on this channel, I help you become a data literate with Masterly Data strategy. If you're new to this channel, welcome. I drop an episode 3 times a week to decode data and help you grow with your data understanding. Be sure to hit the subscribe button and the bell icon. You get notified every single time I drop an episode with data energy. Now, if you're already part of this community, welcome back. It's always awesome to see you over here. So what is this data velocity? Data velocity refers to the speed of data processing. It's a hot topic relevant to data challenges every industry is going through, specifically when everyone wants to do things as fast as possible. Broadly speaking, when we talk about the data velocity, it can be categorized into these two parts: data streaming, data batching. Those days are gone when we were okay to process the data day minus 1 hours or maybe minutes behind. Life was simple and less competitive. But today, in this present world, the business need to make sure that they are able to process the continuous flood of data. They need to react in a timely manner to harness the data to take its best and greatest advantages. Let's move ahead and understand the architecture approaches to address this data velocity challenges. Principle number 1, Lambda Architecture. Well, for me, it seems like the Greek architecture is not just famous within the artists and archaeologists, it's also famous in the big data world. Starting from Lambda and few other that we're going to be discussing down the line. Anyways, let's talk about the Lambda architecture. Lambda architecture is the most powerful and most adopted big data architecture that employs both batch as well as streaming process method. And this method was basically proposed first by Nathan Mars. Okay, now let's get onto the screen and walk you through with the entire Lambda architecture end to end. This architecture builds a relatively 3 independent layers: batch layer, speed layer, serving layer. Allow me to explain each of this layer one after the other, right? The batch layer that manages historical data and recomputing task on your entire data itself. At the beginning of the batch layer sits the data storage, where all the source data is dumped. Yet the original data remains unchanged. It is an archive of raw historical data. It's important to note that the data remains unchanged here. Only data is added from the sources. From this data storage, the data travels to processing stage and results in the batch view. Well, did you know there are 2 benefits of having the batch layer? A, even if you lose the entire data on your views, you can reconstruct that from your data storage. B, because batch layer runs on the entire data set and thus allow the system to give you the most accurate results. The second layer, which is a speed layer, this layer is responsible for processing the data continuously by not caring if data is incomplete or needs some fixation and so on and so forth. It does not pre-process the entire data. Instead, it undergoes the incremental process to store and update the data in real-time views. Benefit of having the speed layer is it decreases the cost of data processing. Why? Because we don't need to recalculate all the available data every time. Instead, concentrate on a small portion of data that is coming recently. But this might also introduce limitation at times because we do not do a full reprocessing of the data. The results are likely to be less accurate than the batch layer itself. Merge view is not a separate layer altogether in Lambda architecture, but it's just a wrapper on top of your batch view and the real-time view. This helps in fast response to the user queries. But at times, user might not want to do this merge view. They wanted to access the data directly from the batch or real-time views. Ultimately, the third layer, which is a serving layer, which is nothing but the ultimate layer to project or present data, or a layer for user to access the information. Here's a reference architecture that I have pulled out of the Digital Talk website. You can go through those details. I'm going to share the links below. You can check it out later. Principle number 2, Kappa Architecture, another Greek letter word. I'm not sure the right pronunciation of this letter, whether it's Kappa, I don't know. Anyways, the biggest advantage of Kappa architecture is it does not need batch layer whatsoever. The entire data is being processed using the streaming systems within the speed layer alone itself. Let's jump on the screen and figure it out how this whole thing works. Now here's a question, why do we need a batch layer at all? Can we not write everything in just one speed layer? But here's the catch, right? In Kappa architecture, you literally do not have a data storage as in the batch layer. But you need an immutable data log system to have a sequence of events with timestamp in addition to the storing of your actual data. So in this architecture, you have an immutable data storage, which most likely is a message broker where data travels into the real-time processing and results into the views and finally shown up in the serving layer. If you look at it, the team can develop, test, debug, maintain and deploy the system in a single processing framework. Sweet, isn't it? Although the Kappa architecture looks concise, it is relatively difficult to implement, specifically for the data replay part. Now here's a Kappa reference architecture which I pulled out from the Digital Talk website again, so that you can have a consistent view of Lambda as well as the Kappa reference architecture and see how they differ with each other. Now let me pause for a second before we jump on understanding the use cases of when to use Lambda architecture and when to use Kappa architecture. Are you started to see the value? If yes, can I request you to smash that like button because I like it, my team loves it, and so does the YouTube algorithm. Okay, now let me talk about few basic use cases that might help you understand when to use Lambda architecture and when to use Kappa architecture. Now with regards to Lambda architecture, take just 2 points. A, when you have the requirement not to erase any of your data, additionally able to add and update new data because of your company policies or compliances or whatsoever. B, when you have a user demand to access the real-time information regardless of having an access to the historical view, right? Then perhaps you might actually want to consider Lambda architecture approach. Now with regards to Kappa architecture, when your real-time view information as well as the historical information is aligned, perhaps that would be the best option approach for you to go with Kappa architecture. Now, if you got a value from this episode, hit the like button. This is me signing off. You would mean the world to me and my team. If you're with us, you're going to be mastering data. Thank you.